Every winter, people fall through ice. A walker crossing what looked like a solid river. A fisherman who misjudged the thickness. Sometimes it's a child, a dog, or even a vehicle that went through on a frozen lake. Sometimes they make it out. Sometimes they don't. When someone disappears beneath the ice, everything changes. Rescue is no longer the focus. It becomes a controlled search in an environment with no direct way up. This is how under-ice search actually works. The first to arrive is the Public Safety Dive Team, a specialized unit trained for underwater recovery operations. Before anyone enters the water, the team reads the environment. The size of the body of water, distance from shore, estimated depth, and most importantly, ice stability. Because if the ice shifts or cracks during the operation, the entry hole becomes a trap. Getting to the site is its own challenge. Depending on ice thickness, the team moves on foot, crawling to distribute weight across unstable sections, or by airboat, a flat-bottomed vessel that glides across the surface without breaking through. Once on site, they cut the entry hole. Always at a safe distance from the original breakpoint, ice near the edge is unpredictable. The entry hole is typically cut in a rectangular or triangular shape, large enough to allow the diver to enter and, if necessary, to bring a victim to the surface. The edges are smoothed out before the dive begins. Sharp ice can tear a dry suit or damage equipment, and that's not a risk anyone takes underwater. Under-ice search comes with 3 factors that make it unlike any other dive operation. The first is temperature. Water near freezing pulls heat from the body far faster than air ever could. Without proper equipment, hypothermia becomes a real risk. Cold affects not only the diver, it affects the gas supply. According to basic gas laws, when temperature drops, pressure drops as well. A cylinder filled in warm conditions will show lower pressure once exposed to near-freezing water. And under stress, the diver breathes faster. These 2 factors combined mean the gas runs out sooner than planned. Physics doesn't stop underwater. The second factor is visibility, or the lack of it. Unlike open water, under ice there are 2 sources of darkness working against you. Ice and snow block natural light from above, and any movement near the bottom disturbs sediment, turning the water into a wall of silt within seconds. A diver can lose all visual reference within seconds of entering the water. No horizon, no light, no sense of direction. The third factor is psychological. In open water, a diver always has one option: go up. Under ice, that option doesn't exist. The ice becomes a solid ceiling. There is only one controlled way back to the surface, the entry hole behind him, the same hole he entered through. That's it. Every decision made below that ice has to be the right one. Because of these conditions, divers use specialized equipment, dry suits for insulation, and cold water regulators designed to operate in near-freezing temperatures. Every piece of gear is checked twice before entry, because once the diver is under the ice, there is no quick fix. The working diver is connected to the surface by a single line, the tether or safety line. It's his lifeline, his GPS, and his only way to communicate, all in one. In some operations, the line carries a communication wire or an air supply, making it what's known as an umbilical. But in most under-ice search operations, it's a standard tether. Simple and absolutely critical. On the surface, one person does nothing but manage that line. This is the tender. He keeps the tether taut, reads every movement the diver makes below, relays signals, and tracks direction and time. He is the diver's only connection to the world above the ice. There's always a second diver ready to enter the water, the standby diver. He goes in only on the supervisor's order, but he's already suited up, so there's no time wasted. The team is in position. The operation begins. The working diver approaches the entry hole. Gear check, signal check with the tender, final briefing from the supervisor. Then he enters the water. The first thing that disappears is the light. The ice overhead becomes a barrier. Behind him is the only controlled way back to the surface. In the darkness, there is one reference point, the safety line in his hand, pulling back toward the entry hole. The tender above feels every movement. Tension in the line tells him more than any words. The search pattern depends on the situation. One of the most common under ice is the arc search. The diver sweeps in wide arcs outward from the entry hole, while the tender pays out the line one measured step at a time, slowly expanding the search area. Methodical, no rushing, but with a clear understanding that time is limited. In near-freezing water, the working diver has between 15 and 25 minutes, depending on equipment. After that, mandatory ascent, no exceptions. Regardless of what was found, the standby diver is already waiting. The search doesn't stop. It transfers. When the diver surfaces, the operation isn't over. Even in a dry suit, the body has been working under stress in near-freezing conditions. The first priority is getting the diver away from the entry hole and into a warm environment. Hypothermia can develop even after the dive is finished. Below the surface, there is a coordinated system at work: line management, communication signals, time tracking, diver rotation, and constant risk assessment. Under the ice, you don't rely on visibility. You rely on procedure. Because in an environment where there is no way up, discipline is what keeps the operation controlled and brings every diver back to the surface.